A steam engine is a type of heat engine that converts the energy stored in steam into mechanical work. It operates on the principle of converting thermal energy into kinetic energy through the expansion of steam. Here's a basic overview of how a steam engine works. Components of a steam engine. 1. Boiler. This is where water is heated to create steam. The boiler uses a fuel source like coal, wood, or oil to boil water, producing steam under pressure. 2. Steam cylinder. The steam produced in the boiler is directed into the steam cylinder. This cylinder contains a piston that can move back and forth. 3. Piston. The piston is a cylindrical component that fits snugly inside the steam cylinder. When steam enters the cylinder, it pushes against the piston, causing it to move. 4. Crankshaft and connecting rod. The piston is connected to a crankshaft via a connecting rod. As the piston moves, it rotates the crankshaft, converting linear motion into rotational motion, which can be used to drive machinery. 5. Exhaust valve. After the steam has pushed the piston, it is released through an exhaust valve, either to the atmosphere or back to the boiler in some designs. This allows fresh steam to enter for the next cycle. How it works. 1. Generating steam. Water is heated in the boiler until it turns into steam. As the water heats, it increases in pressure. 2. Entering the cylinder. High-pressure steam is allowed to enter the steam cylinder, where it fills the space behind the piston. 3. Piston movement. The pressure of the steam pushes the piston forward. The linear motion of the piston is then converted into rotational motion by the crankshaft. 4. Exhausting steam. Once the piston has reached the end of its stroke, the exhaust valve opens, allowing the steam to escape from the cylinder. 5. Cycle repeats. The cycle then repeats with the next burst of steam pushing the piston back in the opposite direction. Types of steam engines. Single-acting engine. Steam acts on one side of the piston, usually with a return spring or atmospheric pressure on the other side. Double-acting engine. Steam acts on both sides of the piston, allowing for a more efficient engine with the piston moving in both directions. Efficiency. Steam engines have historically been important in the development of transportation and industrial machinery. However, they are less efficient than modern engines like internal combustion engines or electric motors due to energy losses during the steam process and heat dissipation. Conclusion. In summary, a steam engine works by converting the thermal energy of steam into mechanical energy through a cycle of heating, pressurization, expansion, and exhaust. Though largely replaced by more efficient technologies, steam engines played a crucial role in the Industrial Revolution and the development of modern engineering.